So let's look at some examples of what we'll see for this type. So these are examples. If position is given by x of t equals 6x to the fourth minus 2t cubed plus 1, what is the acceleration when t equals 1? So in this case, we're not asked about when it's increasing, decreasing, minimum, maximum, whatever. All we're asked for is the value. So all we need is to find an equation and then plug 1 in for t. So we know that x of t, position, is 6x to the fourth minus, oops, this should be a t, my bad, plus 1. The derivative of that is velocity. So that would be 24t cubed minus 6t squared. And then the derivative again gives us acceleration. 3 times 24, 72t squared minus 12t. So to find a of 1, when t equals 1, I'm just going to plug that in. 72 times 1 squared minus 12 times 1. A of 1 equals 66. For these, we like to have units on them. Again, I didn't put units in this problem, but we'll say that position is in meters, time in seconds. So that means the 66 meters per second squared. Let's look at a few more. The velocity of a particle is given by v of t equals 3t squared minus 4. So our first problem, let's find the acceleration at time t equals 3. Again, we just want an equation for acceleration, so we're starting off with velocity. We can just take the derivative and then say, okay, when t equals 3, 6 times 3 is 18. One thing, it's not so much of an issue for this problem, but for more advanced problems, when we have the calculator, we can do the following. We can do n-deriv. So let's see, that's math 8. And then we can put in our 3t squared variable, and then the number that we want it at, and lo and behold, that gives us the same answer, that 18. You will occasionally run across problems where you can use a calculator, but you really can't do the derivative by hand very easily. Make sure that you know about that shortcut. Going the other way, we could also say if the position at time t equals 0 is 5 meters, what is the position at time t equals 3? Since position is the antiderivative of velocity, that means if we take the integral from 0 to 3 of v of t dt, that's going to give us the position at time equals 3 minus the position at time equals 0. Now we know that the position at time equals 0 is 5 meters, so I can pop that right in here. We're looking for this, and we can find this. This is the integral from 0 to 3 of 3t squared minus 4 with respect to t. When we simplify this, that's 15 minus 0 equals position at time equals 3 minus 5, so we add 5 to both sides. Got 20 meters. We can also ask something like this. What is the average velocity from 0 to 3? Okay, the first thing to remember is our formula. So we know that with any sort of average, we've got the average from a to b is 1 over b minus a, average or an integral from a to b of f of x dx. So if we're looking for average velocity from 0 to 3, we're going to do 1 over 3 minus 0 times the integral from 0 to 3 velocity, like that. Now there are several ways to do this. One is the one that we've just done. So we just found the integral from 3 to 0, or from 0 to 3, excuse me. We just did that right here. We know that that is 15, because we didn't do this part, so 15 was what we came up with. There are several ways to get this. We can either use v of t equals 3t squared minus 4 and integrate. Or we could use the fact that the integral from 0 to 3 of v of t dt is the position, so let's call that p of 3 minus p of 0, which actually is pretty much what we're doing here. If we take the antiderivative, we're getting the equation for position. Any of those we can do, but whatever it is we're going to do, we are going to be multiplying by 1/3. So let's just go ahead and do it the same way that we did it before, since we don't actually happen to have position at the moment. So that's going to be the integral from 0 to 3, 3t squared minus 4 dt, so that's 1/3. Like that. And that's the average velocity. We were measuring in meters per second. We could also do this using finite integral on the calculator. So if I did that, I would go to Math 9. Let's see, that was 3 variable squared minus 4 from x to 0 to 3. If I do that, I get the same thing, but you want to make sure that you don't forget that 1/3. This is in contrast with another problem like this. What is the average acceleration? You have to be really careful what you're being asked for. So you want to make sure that you set up your equation based on a of t. So this is going to be 1, 3 minus 0, integral from 0 to 3, but in this case of a of t dt. Now, if we come back here, we did find the equation for a of t. We took the derivative, but we're going to have to sort of undo that. We're going to have to go back up and take the antiderivative and get back to velocity again. So there's not a whole lot of point in doing this problem the way that we did the one up here. But notice that we can use this to solve it in a little bit of an easier way. We know that the integral from 0 to 3 a of t dt is its antiderivative, which is velocity of 3 minus velocity of 0. So I'm just going to make this be 1/3 and then v of 3 minus v of 0. So I can just plop that in. Let's see, velocity 1/3, 3, and then t is 3 squared minus 4, and then minus 3, 0 squared minus 4. Right like that. I'm just using that equation for velocity and substituting. So this is 1/3, 3 times 3 times 3 is 27, minus 4, minus 0 minus 4, so minus 0 doesn't matter, that becomes plus, negative 4 plus 4 is 0, that's 1/3 times 27. 27 divided by 3 is 9. Average acceleration, that keeps the same units as acceleration.